All right, so let's go ahead and draw another cyclohexane. So line, line, right? You can tell they're approximately equal one another. And then draw to the midpoint, line, midpoint, line, 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 right? Not the greatest ever, but still pretty decent. And so now we need to think about what these guys actually look like. Where are these hydrogens? Remember, each one of these has a hydrogen. And so it's pretty hard to see in this picture, but what you need to be able to do is picture the three-dimensional image in your head, right? So you can see the chair conformer down here, same one we drew, and you can see that we have two carbons or two hydrogens on each carbon. And so there's actually differences between these hydrogens. Some are what's known as axial, some are known as equatorial. And so to draw these axial ones, they're all either pointing straight up or pointing straight down. So what we do is we have a hydrogen pointing straight up, right? It doesn't make sense to have this one pointing straight down. The bond angles wouldn't work right there. So there's one axial hydrogen, another axial hydrogen, another one, another one. This one points up, and then this one points down. So these are all what's known as axial hydrogens. And then we can draw in the equatorial ones as well. So these equatorial ones, you want to draw them as parallel. So for example, this line right here, this hydrogen should be approximately parallel to it. For the hydrogen over here, it should be approximately parallel to this line right here. And then the same thing on this other side. And then for these two in the middle, they should be, for these two in the middle, they should be parallel to these lines on the sides. So there are all of our hydrogens. These are what's known as equatorial. And so that might be hard to picture in this little image, but you need to go from this top image on your piece of paper to this bottom image in your head, right? We can see our carbons, 6 carbons, 6 carbons, and then we can see some of the hydrogens are kind of around the equator of the ring, while other hydrogens are on the kind of north and south pole or the axis of the ring. Here's just a kind of top-down view of that. So we can see these top 3 being axial. We can see all of our equatorial, and then there's more axial hydrogens underneath these carbons. Here's just another diagram in your book. This one kind of explains how to draw this relatively nicely. Again, you don't have to be perfect, but it does need to be legible, and it will take a little bit of practice, right? So there's your cyclohexane with all of these kind of, at this point, these would be methyl substituents, or you could put little hydrogens on them as well. And that's it. Well, one thing that you kind of want to also think about is, yeah, we'll talk about it later. That's it.